In the interconnected world of advanced technology, one company stands as an almost invisible, yet utterly indispensable, cornerstone. Headquartered in a quiet Dutch town, ASML is a name unfamiliar to many, but its creations are vital to every smartphone, AI server, and cutting-edge computer chip on Earth. This ultra-secretive Dutch firm holds an absolute global monopoly over the most advanced machines required to fabricate modern processors, a position of unprecedented power that has made it the ultimate choke point in the intensifying US-China tech war. Its influence shapes not just boardrooms, but global geopolitics. To understand ASML's dominance, we must first grasp the critical process it enables, photolithography. At its core, lithography is like taking a microscopic photograph. It's the method used to print intricate circuits onto silicon wafers, layer by microscopic layer. Think of it as stenciling patterns onto a chip. For decades, this process has been foundational to semiconductor manufacturing, with companies like TSMC and Intel relying on increasingly precise lithography machines to etch ever smaller, more powerful transistors onto their chips. Without this precision, advanced chips simply cannot exist. The real game-changer for ASML, and for the entire tech industry, was the advent of extreme ultraviolet, or EUV, lithography. For decades, chipmakers relied on deep ultraviolet, or DUV, light. But as circuits shrank to atomic scales, DUV light waves became too large to print the necessary patterns. EUV uses a much shorter wavelength of light, allowing for significantly finer details and denser transistor packing. According to industry reports, this technological leap wasn't just an improvement, it was a paradigm shift that unlocked the next generation of chip performance, effectively rendering prior methods obsolete for leading-edge nodes. ASML didn't just stumble into this monopoly, it was a strategic, decades-long journey of immense investment and relentless innovation. While competitors like Canon and Nikon also developed lithography machines, ASML committed fully to the monumental challenge of EUV. Sources familiar with the company's history highlight that the financial and engineering hurdles were astronomical, requiring collaboration with major partners like Carl Zeiss for optics and dozens of other specialized suppliers globally. This concentrated effort ultimately created a barrier to entry so high that no other company could realistically compete, solidifying ASML's singular position in the market. The direct consequence of ASML's EUV monopoly is the complete dependence of the world's leading chip foundries, particularly Taiwan Semiconductor Manufacturing Company, or TSMC. TSMC is responsible for producing over 90% of the world's most advanced chips, including those for Apple, Qualcomm, and NVIDIA. Industry analysts confirm that TSMC cannot print a single advanced chip, those utilizing 7-nanometer processes and below, without ASML's EUV machines. This symbiotic relationship means that the entire global supply of cutting-edge microprocessors hinges on the continued operation and availability of ASML's highly specialized equipment. An ASML EUV machine is not merely equipment, it is an engineering marvel, a factory within a factory. Each machine is housed in 40 shipping containers, requires 1,200 cables, and weighs 180 tons. Its construction involves over 100,000 components from a global supply chain. The complexity and precision are staggering. Priced at well over $150 million per unit, some reports suggest closer to $200 million, these machines are not just expensive but incredibly complex to build, transport, and maintain. Acquiring and operating them requires immense capital and specialized expertise, further cementing ASML's unique position. This unprecedented technological monopoly has placed ASML directly at the center of global geopolitical tensions. As nations increasingly recognize the strategic importance of semiconductor independence, access to ASML's EUV technology has become a critical vulnerability. Experts in international relations now refer to ASML as the ultimate choke point in the global technology supply chain. Any disruption to ASML's operations or any restriction on its sales can send ripple effects across the entire tech industry, impacting national security, economic growth, and the development of future technologies for every major power. The strategic significance of ASML's choke point status is most acutely felt in the ongoing US-China tech war. The United States, aiming to curb China's technological advancements and military modernization, has increasingly focused on limiting Beijing's access to advanced semiconductor technology. According to White House statements and policy documents, preventing China from acquiring advanced chip-making capabilities is a top national security priority. This strategy inherently requires controlling the sources of such technology, and ASML, with its indispensable EUV machines, sits squarely in the crosshairs of this global power struggle. The Netherlands, ASML's home country, found itself in an unenviable position, caught between its economic interests and diplomatic pressure from the United States. While ASML's sales to China represent a significant portion of its revenue, the Dutch government faced intense lobbying from Washington. Reports from Reuters and the Wall Street Journal detailed how U.S. officials argued that allowing advanced chip technology into China posed a direct threat to global security. This pressure ultimately led to a difficult decision for the Dutch government, balancing national sovereignty with international alliance obligations. In January 2023, the Dutch government, under pressure from the United States, officially announced new export controls directly impacting ASML's ability to sell its most advanced technology. The restrictions specifically target the export of EUV lithography machines to China. This decision effectively cuts off Chinese chip manufacturers from acquiring the only equipment capable of producing the most advanced chips. While ASML's DUV machines, used for less advanced nodes, are still permitted for sale, the ban on EUV equipment signals a clear intent to slow China's progress in high-end semiconductor fabrication, with profound implications for its domestic tech ambitions. Faced with these restrictions, China has doubled down on its efforts to develop its own domestic semiconductor industry, aiming for self-sufficiency. Billions of dollars have been poured into state-backed initiatives to research and develop indigenous lithography technology. However, experts like Dan Wang, an analyst at Gavecal Dragonomics, assert that replicating ASML's EUV capabilities is a task of immense, perhaps insurmountable, difficulty. The sheer complexity, the decades of R&D, and the intricate global supply chain required mean that even with vast resources, China faces a formidable challenge to catch up, at least in the short to medium term. Why is ASML's EUV technology so difficult to replicate? It's not just one invention but a culmination of thousands of patented technologies and decades of incremental breakthroughs. The process of generating EUV light, for example, involves firing powerful lasers at droplets of molten tin 50,000 times per second, inside a vacuum chamber. This alone is a feat of engineering. Then there are the ultra-precise mirrors developed by Carl Zeiss, so flat that if scaled to the size of Germany, the largest bump would be less than a millimeter high. Such extreme precision and complex integration are simply beyond current global capabilities outside of ASML's ecosystem. ASML's success is also deeply rooted in a unique, highly specialized global ecosystem of suppliers and talent. The company itself acts as an integrator, bringing together components from hundreds of companies worldwide, each at the pinnacle of their respective fields. This includes American firms for software and laser technology, Japanese companies for specialized materials, and German optics expertise. This intricate web of interdependencies, developed over decades, forms a moat that is nearly impenetrable. Building a competing ecosystem from scratch would not only require colossal investment but also an unprecedented level of international scientific and engineering coordination. The implications of ASML's choke point status extend far beyond the US-China tech rivalry. Its singular position highlights the fragility of global supply chains in an era of increasing geopolitical fragmentation. Any event that impacts ASML, whether a natural disaster, cyber attack, or further political interference, could cripple the world's ability to produce advanced semiconductors. This vulnerability has spurred calls for greater diversification and regionalization of chip manufacturing, yet the reality remains that for leading-edge chips, there is currently no alternative to ASML's EUV technology, making its security and stability paramount for global technology. Looking to the future, the path forward for advanced chip manufacturing seems inextricably linked to ASML. While research into next-generation lithography, such as high-NA EUV, is ongoing, ASML is once again at the forefront of this innovation. This suggests its monopoly will likely endure, if not strengthen, for the foreseeable future. Without ASML's continued advancements, the progress of Moore's law, the principle that the number of transistors on a microchip doubles approximately every 2 years, would slow dramatically, impacting everything from AI development to quantum computing. ASML doesn't just enable the future, it actively defines its pace. ASML's unparalleled market position is reflected in its staggering financial performance. With annual revenues exceeding €27 billion in 2023, and a market capitalization often fluctuating around $350 billion, ASML is not only a technological giant but an economic powerhouse. These figures underscore the immense value placed on its unique capabilities by global investors and the tech industry alike. This financial muscle also fuels its massive R&D budget, ensuring it stays ahead of any potential challenges and continues to innovate at a pace unmatched by any other entity in the chip equipment sector, reinforcing its monopoly. Despite its pivotal role, ASML remains a relatively silent giant in public discourse. This secrecy is partly by design, reflecting the highly competitive and sensitive nature of the semiconductor industry. Yet, its understated public profile belies its profound global impact. The company's influence permeates every aspect of modern digital life, from consumer electronics to advanced defense systems. Its story is a testament to how specialized technological leadership, once achieved, can become a leverage point of immense geopolitical significance, shaping the contours of global power for decades to come, quietly and decisively. ASML is more than just a company, it is the linchpin of modern technological advancement. Its absolute monopoly over EUV lithography machines makes it the single indispensable entity for producing the most advanced chips, creating a crucial choke point in the US-China tech war. The future of AI, quantum computing, and even national defense fundamentally rests on ASML's continued innovation and the geopolitical decision surrounding its technology. For the foreseeable future, whoever controls ASML's machines, or at least their access, holds a significant key to building and controlling the future itself. It's a stark reminder of how specialized technological mastery can confer unparalleled global power.